Okay. Hi, everyone. My name is Bruno, and this is Agentic coding in ChemApp for Python. Basically, I want to show you how to let an AI agent write and run code so it can perform thermochemical calculations with ChemApp for Python. I'm going to do this working through 4 examples. Oh, this isn't cool. Sorry. Okay. First, asking an AI agent from a chat session on a browser. Then, scaling up from that script with VS Code. VS Code is an integrated development environment for programming languages. And then third, by adding domain knowledge, we build something more interesting for a real UI. And fourth, we turn that all into an app that any engineer can use. But first, before any AI, let's define the domain. What is the application case we are going to look at? We decided to pick metal dusting because it's one that builds from a very simple principle where we can first just analyze a carburizing atmosphere. The key principle is whether that atmosphere promotes activities of carbon equal or higher than 1 in a dormant phase. And if that happens, that promotes formation of carbides in a steel, which leads to metal dusting. So we want to prevent that. In FactSage, you can quickly analyze this in a very simple setup by defining your system, reactant amounts, species, your selected phases, gas phase, and we set the graphite phase as dormant, for example, so we can analyze the effect of the system on the activity of carbon freely. And as a result, for this particular composition here, we can see activity at 1.2916, meaning that it is higher than 1, and that would be a metal dusting risk in this case. Activity is higher than 1, it could form carbides. Okay, very simple case. Can we reproduce this with ChemApp for Python? I know I can. I know most people can. But how about doing that from a chat session with an AI agent? That's interesting. Let's see. That is the first case. So how can we do this? We need to build a prompt that enables the AI agent to do it. The prompt needs to provide enough information for it to do. So we start with informing what data file we are going to use, exported from FactSage, what system it is, what components and phases, what we want to calculate, the exact conditions that we put in FactSage. We wanted to be able to reproduce that, and also what we wanted to report. We want to see, besides the activity of carbon, the composition of the gas phase and the partial pressure of oxygen. We want to see all this so we can confirm and validate that the script is correct. Cool. Now, this is a demo. I'm going to copy this prompt live, place it in my AI agent. I'm using Claude. You can use ChatGPT or many others. Nowadays, there are so many. I'm going to paste it here and hit run. Unfortunately, this takes 4 to 5 minutes. Of course, I did this before already. But you can see it started. I have a pre-recorded video here because we don't have that much time. And we're going to see a sped-up version of what it does there. It says it's crafting the script. It's looking for the correct functions to call in ChemApp, checking the consistency of everything, architecting, mole fractions approach, and all of that. And then it produced something. You see? From here, we can already see that it looks like a Python script. So let's confirm. I'll go back. The original prompt is still running. It takes a bit longer. But let's see. The one that from the initial session. I still have it here. although it looks like a Python script, the best thing I can do is just try to download it and run. So I'll click on download here. I'll go for my particular example folder here. Save it. In that folder, the only other thing I have there is that CST file I informed the agent about. And now we want to be able to run this in Python. You can run Python in many different ways. I'm going to do the very dirty work here with the command prompt. I first need to activate my ChemApp for Python script, my ChemApp for Python environment. If you don't know how to do this, it's quite small ChemApp. And then from it, I can say Python, please run this script. Hit enter, and then I see a bunch of numbers. Are these numbers meaningful? We need to check, right? This has been written by an AI agent. I have no clue. And that's why we have FactSage. So I also have the results window from FactSage here. Zoom gets in the way for me, but I'll try to manage this. Yeah, not really good. I'll do the opposite, like this. So I just want to check a few numbers to confirm I'm on the safe side. So let's say for the amount of CO2 in the gas phase, the values are the same. 3.31, 36, that looks okay. E plus 1. Same for H2, 22999, 18485, blah, 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 blah. It looks okay, right? And how about the activity of carbon? The most important feature for this analysis. It doesn't look great in this view. Maybe like this. Remember from the beginning? 1.2916. So over here in the script, if I can show it, on the top we have here the same value, which means many things. The agent was not only able to write a valid Python script, as it was able to recover all the correct Python, ChemApp for Python functions, place them in the correct order, interpret our system exactly as we want it, and reproduce something that you would only get in FactSage, or if you already knew how to use ChemApp for Python. And it did all of this just using a text block that we gave it to it. It's quite a lot. From what I just said, I guess you can imagine you can do much more directly. I could start asking for different shapes of results and things like that here, but I will not do this now. I want to go further. How? What else can we do? Well, these are the results. Let me put this in presentation mode. Oh, not this again. Sorry. I'll just keep it like this. This is a demo. It's easier this way. So the second example is scaling this up. How about running thousands of equilibria from inside the VS Code IDE? VS Code helps programmers a lot because it integrates all the tools programmers need to develop faster, to write code faster, and nowadays, for sure, to integrate with AI models, AI agents in a nice way. So it makes sense to use VS Code. But then the issue is still the same. We need a proper prompt to achieve what we need. In this case, we are going to build from the previous script we obtained in the first prompt. And we say, first, turn that script into a function dependent on temperature and the amount of CO2 and CO. Then let's sweep the temperature and CO2 amounts with a min and max value and steps defined there. And by the end, let's ask for a more fancy plot, because we saw you can do these things. It is reliable, it reproduces FactSage, so now we can ask for a bit more. We want a heat map of the activity of carbon over temperature and the amount of CO2. Drawing even a contour line for the isoactivity of carbon at 1 defining the metal dusting threshold clearly for us. So if I do this, what I can do is I can open this folder in VS Code. And you see in VS Code we have the different AI models here. I'm going to use Claude again. And I can just type here the prompt, and it will pick up the context of where I am in this folder and build from that. So there's just one hiccup here, because when I copy and paste this prompt, it will be pasted as a image. And I don't want this, so let me just create a new file. Yeah, paste it here first so that it turns into text, and then I can paste it here. And there you go, just to prove to you that this is exactly the same prompt that I had there. And if I click run, again, this will take 4 to 5 minutes. Not so long, but for the presentation, a bit too much. And I have the pre-recorded video also. So let's see it in action. It was very fast at the beginning, but it was just pasting the prompt. And then you see how it works. It tells us what it's doing, what it needs to do. It checks the current folder, everything that is there. And it's trying to reproduce what we asked for. When it's done, it says so, and it provides the instructions to run the code. In my prompt, I also said, you don't need to run this now. I'll do it myself. So it says some instructions here on how I can reproduce it. But I already have Python. I already have everything that I need. So what I'll do is, this is the original one, still running. I'll just stop this one. I'll open my folder where it already happened. Close this. And again, open with code. I can restore the session even. Yeah, so just to see, it's exactly the one we were at. And in VS Code even, it becomes a bit nicer to run this script. I can just click on run. There's a run button there. It picks up on the Python environment that was set up for it. It's running the script. You can see here on the bottom. And then the result. And here is our plot, exactly as we wanted. Temperature on the x-axis, CO2 on the y-axis, and a mapping for the activity of carbon activity, where red means higher activities, blue means lower activities, and a nice threshold line there for the onset of the metal dusting. A highly valuable plot for this particular phenomenon. And we've just ran something like, what was it? Almost 10,000 points in a few seconds. We didn't write a single line of code. Interesting, right? What else can we do? Well, I could just keep asking for nicer features, nicer plots and things like that with the current setup, but we can go even further. We want to apply this to a real steel alloy. But in order to do that, we need a bit more information. The agent can go as far as its knowledge is available, as the knowledge that it has available, but we can provide a bit more and achieve exactly the kind of thing we want in our domain. So I would like to ask my colleague Ömer to come here and present this part, because he was the one who created this domain knowledge files, which enable us to do a lot. So just a second.
You hear me well? Ah, okay, perfect. So Bruno showed really nice 2 example cases with 2 different complexities. The first one, he used the web interface that we use for our daily questions to ChatGPT or the other agents. The second one was a bit more complex problem that he showed this nice diagram with the property in the color map, which required to then move to a proper IDE, an integrated development environment, and to do a coding there. Maybe I go to the presentation mode.
It's a bit tricky. Very good, very good.
Okay, yeah, it looks a bit bigger now. So what happened basically is Bruno created a prompt, interacted with the agent, and agent provided a result. But what actually happens in the agent side? What do agent know and what it is capable of to provide the results? As we all know, agents are quite good at programming because programming people were very into the open source philosophy, so that all the agents available could be trained in that sense. But agents are also good at thermodynamic knowledge, not as good as programming, but you may have asked some questions before, and they answer quite okay, although they hallucinate. The general agent knowledge is not that different from a human knowledge. In fact, here I want to give a personal experience of mine, where I did my first internship experience at Max Planck Institute at 2022. I joined to the group that we try to produce metals using a plasma technology, and we wanted to know our gas atmosphere, what is happening there. That's why we had a mass spectrometer. And my task was to calibrate this mass spectrometer into our furnace. The problem was the only person who knows about this device was leaving at the same day I arrived. So what I was left was the documentation, some type of documentation that I need to read through, 300 pages, all about the mass spectrometer. I read it. I spent 6 months, close to 6 months. It worked at the end. Agents also do that. Agents read documentation. In Bruno's example, you have seen the agent actually reach to the online available ChemApp for Python documentation to write an actual script. But for me, what was really difficult is I had one wish, that I wish there was someone that I can ask specific questions about the problem, so that I don't need to go through the whole documentation. And this is our domain knowledge. We seek for some experienced people to ask very specific questions, like as if I could ask Maurice, to Philip, to Joao about a certain process. Or this can be also quite programmatically important case that if you work with ChemApp for Python, you know there is steps that needs to be taken to perform a calculation. And that's why agents perform better when this general knowledge is guided by the domain knowledge. How this is presented? We use the context files and skills. These are documents that contains experience in a compressed form. So agent can read whole documentation. It costs quite a lot of tokens, sometimes a lot of time. But if we can compress this information in a document, which is the most important that we conceive from our GTT's knowledge, our experiences over years, for users like you, so that you can apply this knowledge to your domain expertise, this we believe it contains value for this picture of the general agent knowledge. So what type of value these context files add? These provides expert know-how. As I said, it is as if you could speak to an expert at GTT about a thermodynamic calculation. It's not for a point equilibrium that Bruno showed, and later we showed a map. But what if we go even more complex to define a process metallurgy? Then we need more knowledge. Then we need to know about workflows. These documents will lay out the right order of steps, which calculations to do first. Maybe you want to take your stream and do another sort of operations. This type of information that can be stored in this type of skill files. Finally, we all know that agents hallucinate. And we can restrict this just the right amount so that these documents are reusable. When you close your computer and open again, you don't need to go to the same chat history and write down everything from scratch, because documents are there physically stored in your computer, and they are more consistent because we just restrain them the right amount. If we restrict it too much, then it loses its creativity. So we try to tune it right to have the best performance overall. How these documents look like, Bruno and I ordered this in different categories based on the needs. Agent then reads through the description of these documents. So this is at the top, usually there are the title and description. Agents know what to read and when to read. And then such documents have a core, the information, the experience stored inside, and then it references, it creates a web of information so that a document can lead the agent to another document and to another document, but in a very efficient way, so the agents can work like teams working in your companies or in your groups in the academia. So now Bruno will show a more a difficult case for agent to solve, and we hope that agent can get a bit of tricks by using these context files. Thank you.
Thank you very much, Ömer. Yep. So, with all this new context, a lot more domain knowledge, what can we ask for? Let's try with real steel, stainless steel, different steam levels in the atmosphere, and we want one failure mode map plotted in a nice way. So oxidation even included, not only metal dusting. For this, again, let's go for the prompt. We inform that we are now going to use a richer data file that we need for the steel part. We also want to say to the agent, and this is where the domain knowledge comes in, we want to consider the corrosion risks. So this could be quite open to interpretation, right? So one of the domain knowledge files is taking care of this, categorizing exactly what kind of risks are there, how to label the risk based on what phases are stable, what phases are not stable, and the different concentrations of them, so that it can actually classify between metal dusting, iron oxides, and simple passive regime where the steel is safe. We have to tell it where to look for this additional context. You can put this in a, or if you actually use the skills feature, be picked up by the model automatically, but they're exactly the same. And then we ask for this particular parametric mapping with some conditions similar to what we had before, but also now changing the contents of water with 4 different levels. And we want a more rich map with a 4-panel layout. And we also want to see the failure modes for each of those mappings. And that's it. Again, here, I can pick and copy this prompt, and I need to place it in a richer folder where we actually see the reference there, the thermodynamics, and all the files that Ömer was talking about. So the one thing about this example is that it takes much longer to run, so it doesn't help me if I want to run it myself. For once, I'll just run the video here. This is to generate the script. Oops, too fast. This is sped up by quite a lot. This one took about 30 minutes for the model to solve. Not only because it is more complex, but also because we asked for a very fine granularity there for the grid to be covered. So I was a bit too ambitious there, and it took about 30 minutes. Nevertheless, you can do that, and here it's sped up for sure. But I cannot run it also because it will just take too long. So I have also the video here for the run. And it's the same thing. I'll just try to stop it so you can see a bit more clearly. What I did, I even wrote it down because there were 2 Python files being generated. This is the one that actually starts the script. And then I explicitly tell Python which one to start. And that's just it at the beginning of the run. and I hit enter. So we will go through 4 different steam levels, calculating about 2,000 points for each of them. So this is the first level, second level, third one, and the fourth one. Yep. And then it produces also a nice plot, now a richer one, where we see the different regimes for either oxidation or metal dusting. Oxidation here in red, metal dusting in orange, salmon, and the passive regime, the safe one, in green. It also has some nice contour lines, again for the activity of carbon and for the precipitation of oxides. Cool, right? And for the different steam levels, different atmospheres here, other than already changing the amount of CO2. So this is the kind of thing, much richer information that we can get when we use domain knowledge files. Okay. What else can we ask for? Quite a lot, as you can imagine, right? What we decided to focus on is on a very nice application case where we can turn this particular setup into an app even that any plant engineer could try to use and actually receive results without knowing a single thing about Python and maybe not even about FactSage. So in order to do this, we will rely on a Python library called Streamlit. This library allows for creation of graphical user interfaces that run on your browser, relying on a Python backend, which is exactly what we have created so far. So I tell the agent how my app shell should look like with the Streamlit app, reuse all the material it already has there, and I also am quite picky about how I want to look at it. I say exactly what kind of knobs I want to have to tinker with it and check on the different conditions. So I want sliders for the content, chromium content, water content, CO2, temperature, min and max values for CO2 and temperature, different axis selectors and things like that, and a generate button to actually show the map. So I'm just playing around. This is much more fun now. We can keep going. I am a software developer. This is fun for me. Maybe it's not for everyone, but it's fun for me. And then finally, just to make it clear for the agent, I want to see the larger portion of the window, the mapping as a result, right? This should be the most important part there. Right? And so I just tell it to do that. And something that I probably would not even need to write here because the domain knowledge file is also explicitly say, but it's important to only load the data file once because otherwise it takes too long each time you run the script. So just telling the agent to remember to cache it. Okay? Then again, you can imagine what I'll do. I'll copy this. Where is my taskbar now? Close this one. This video as well. I'll go directly for the video. It's a bit safer with copy-pasting. So you see first the agent working. Initially, I paste the prompt there in the IDE as well from the previous results we got to build upon that. And then I'll hit run here again. This one took about 10 minutes to run in real life. Here again in about 20 seconds. Can make this larger. Changing things. The main script here, he did not even change because just the script, but it built another Python script for the app itself. Okay, let's do that. I'll go for that fourth example folder. I want that hint that he gave us, so let's get the command there. And I'll just copy the final part of the command, paste it here to run it. And you see it directly goes to the browser, starts the browser in a new tab, and shows us a new app. So we now have something that takes into account everything we already did. We know it has a valid chemistry. It is reproducing important features of corrosion. And now we can play around. We can change the content of chromium. We can change the amount of water freely. CO2, min and max, CO2 steps. I'll increase this so it doesn't take too long. Temperature, I'll also increase the steps. And the axis, let's change for once between Y and X. The main features here are not shown yet until I click on generate, and it actually went on and added a few more hints about how to interpret the plot. But let's see, when I click on generate, it takes a while, and there you go. You have a working app. It also made something fancy there because it is calculating the amount of the area there that represents the share for the different regimes. Don't know if we need that. We can also ask it to remove it. We could go much, much further, right? Then we can customize this as much as we like. But these are the main features, the most important things, going from one single script for a single point calculation up to an interactive app, which is quite powerful. Now, to wrap up, let's see if I can make this in presentation mode again for you and our live audience online. Yep. Okay. What would you need to reproduce what I did? You would need Cloud Code, or if you want to do exactly as I did, but you can also use any other model subscription. You need VS Code and the Cloud extension, or the corresponding extension for VS Code. ChemApp for Python. You would need a license for it if you want to do the full model. And you also need FactSage to generate the CST files. And as Ömer explained, you also would need to generate your domain-specific files for your particular applications. If you need help with any of this, by the way, you can talk to us in the breakout session this afternoon. And finalizing, what we've made here today shows us that LLM agents couple naturally with ChemApp for Python. User input can focus only on the conditions and the desired shape of the results. And the validation is always possible with FactSage. For any point calculation within all those sweeps that it performed, we could just open in FactSage, check if it is correct. And it's recommended even to do that for particular cases. And that scaling thermodynamic calculations has never been easier, right? We know that FactSage is very reliable, but we also know that it is constrained by our input once at a time, and you need to go to particular areas, click here and there, and that is not so useful for high throughput calculations. But with this, it becomes much easier. And in the end, this applied workflow delivers thermodynamic sound simulations for corrosion studies, this particular case, maybe other corrosion studies. But it can be used for any kind of thermochemical application in industry or academia. There's no restriction here because ChemApp can do it all. The only thing you are limited by is your database. But if you have FactSage, you can do quite a lot. And we invite you all to try at least examples 1 and 2. Start with a small script. Ask for any agent to create an initial script for you. You can do it even with ChemApp for Python Lite, which is available right now and allows you to use up to 3 components in your database. And it's fun. I really like it. Hope you like it too. That's it. Thank you.